Okay, so question 79, indicate the configuration of the asymmetric centers in the following molecules. So for this question, we have three different sub-questions, and I think I'm just going to do one of the three, so I'm going to do sub-question B. What you need to recognize right off the bat is you have to deal with not just one, but two different stereo centers, or two different chiral centers. This blue one on the left and the yellow one on the right. So you actually have double the work that you might have with a regular molecule. It's a little bit simpler. So this is a little bit more higher level of challenge that you might have to deal with, let's say on an exam or something like that. So what we'll do is we'll just take one of these at a time, figure out the RNS configuration, and then move on from there. So for the blue, let's just say for the blue we have four different groups. Definitely is going to be very easy to say that hydrogen is the lowest priority and the bromine is the highest priority. So after that, it gets a little bit, it's even simpler than that, because between the oxygen and carbon, oxygen's obviously higher atomic number, so this is going to be the second highest priority, and then from there we're going to have the carbon. So it doesn't really matter what all of these different groups are, it's just necessary to recognize that this carbon is lower atomic number than the oxygen. So this is going to be the third priority. So now what we have to do is just say, well, is our lowest priority facing away from us? And the answer is yes, it is. So it's fantastic. It's easy work. So now all we have to do is figure out, is it going clockwise or counterclockwise in terms of priority? So it looks like for this case, we are going clockwise. So this is going to end up being an R configuration. So 1, 2, 3. So this is R. Hydrogen is in the back. So that's great. So it looks like for the blue is going to be R. So that was pretty easy, not too terribly bad. So let's concentrate now on the yellow. So again, let's try to find out and see if we have an easy call in terms of priority. And it looks like we do. So we have this hydrogen, which is again always going to be the lowest priority, so this is going to be number 4. And then from there we have carbon right here, this red carbon, and we also have this other group right here, this kind of pink group. And then we also have another group up above, the oxygen. So let's go ahead and I'm going to recolor this hydrogen. I'm just going to use white for that guy. So this is our fourth group right here, or lowest priority group. And from there we are basically comparing this carbon to oxygen. So between these two carbons we have a tie, but this green OH group, the oxygen, has a higher atomic number. So again, we're not really comparing the OH, we're basically just looking at the oxygen itself. So I really should have circled the entire thing right away. So what we're really comparing is this oxygen. And if we needed to break a tie, we could go farther along the chain, but oxygen is going to be the highest priority. So this is going to be number 1, number 4. And so now we basically have to break the tie in between this red and the pink. Okay, so one thing you have to remember is that if you have a double bond, such as with this red configuration, you have to remember that you treat it as if you have two bonds to that same atom. So what that means is that you have this carbon, this red carbon, and you're going to have 3 different groups formally. Informally, you really only have 2 groups bonded to this red carbon, but the way we would figure out priority is to say that this carbon is not bound to just one oxygen, but it is bound to 2 oxygens, and then also a hydrogen. And if we were going to try to break the tie up here, we would say that this carbon, the pink carbon, so this pink guy right here, it is bound to an oxygen, hydrogen, and bromine. So between these, we have bromine, oxygen, and hydrogen. And then, again, the way that I'm orienting these is highest priority on top, lowest priority on bottom. And if we have a tie, we'll just walk our way down. So basically right now, it looks like we're trying to compare the bromine to the oxygen. And between the two, the bromine is going to win out. So bromine is higher atomic number than the oxygen, and there's really no need to walk any further down the tiebreaker tree. So what we have is this group, this pink group, is going to be group number 2, and this red group is going to be group number 3. So in this case, we don't have our lowest priority facing away from us. So again, you can either do a single swap rule, or you can think about it in terms of 3 dimensions. Imagine yourself being behind the molecule. And if that's the case, then you would find out that this red is R as well. So this group is going to be R as well. So I can't emphasize enough just how important it is to make sure that that lowest group is facing away from you. Because if you didn't do that, it would look like this yellow chiral center is an S configuration. Okay, so just to make it a little bit more rigorous, let's do the single swap rule and make sure everything looks good. So let's go ahead and swap our molecules or our attachment points. So we've got our aldehyde right here, and I'm just going to call this bit position 2 because basically this position 2 is this pink group, and there's no real reason to actually draw it out completely. So what we're going to do is just switch the OH and the hydrogen so that this hydrogen can be facing away from us. So hydrogen here, OH here. So this is going to be the highest priority 1, 4, and then 3. Okay, so it looks like this is an S configuration because it looks like it's going in a clockwise manner. But this is after a single swap. So remember that after we do the single swap to figure out the configuration, we have to single swap again. So we're going to actually have an R configuration for this overall, whoops, not the overall molecule, but for this particular yellow chiral center. Okay, so the pink is going to be R, and the yellow is also going to be R. Okay, so this should actually be pink. Okay. All right. The other two should be pretty simple. Once you figure out RNS, and you always remember to swap back after you do the single swap rule, everything kind of falls in place. All right. Next question.